Hi everyone, and welcome to AWS Julie. I'm starting a new series where we're going to talk about AWS fundamentals that you need to ensure that you understand to pass your AWS certification exams. Now, I'm going to start off this series at the Cloud Practitioner and the Solutions Architect levels, and then we'll dive deeper into more fundamentals for all of the AWS certifications. Please remember to give me a like and subscribe and reach out with any questions or feedback. Let's get started and let's dive into what is AWS. So for your certification exam, ensure you know what AWS is. Can you define AWS? Well, AWS says that Amazon Web Services is the world's most comprehensive and broadly adopted cloud offering over 200 fully featured services from data centers globally. Millions of customers, including the fastest growing startups, largest enterprises, and leading government agencies, are using AWS to lower costs, become more agile, and innovate faster. So AWS provides us a way to power our infrastructure while becoming more agile and also lowering our costs. But you also need to understand what is cloud computing. And if you ask around or Google what is cloud computing, you're going to find multiple different answers. But cloud computing basically means that you have to meet certain criteria. Again, there are a lot of great definitions for cloud computing, some simple, some more complicated, but let's break it down and quickly walk through the 5 criteria. The first criteria that we need to meet for AWS to be considered cloud computing is that AWS has to offer an on-demand self-service, which is the ability to provision compute features or capabilities like servers, databases, network storage, and more on demand when that service is needed. Also, cloud computing has to be able to provision resources without any human intervention or interaction to make it an on-demand self-service. AWS gives us the ability to do this from the console, the command line, but also by using application programming interfaces. And we don't need to request or ask anyone. With the correct permissions, you can go in and start building. The second criteria is that cloud computing needs to have network connectivity to access and provision resources that are needed. AWS gives us the ability to build using the AWS Management Console, the command line, HTTP, HTTPS, VPN, SSH, and more. The third criteria is that cloud computing needs resource pooling. Well, what is resource pooling? AWS provides pooled resources to serve multiple different AWS customers. AWS has thousands of servers, databases, and more that we can on-demand provision and build in our own environment. And these pooled resources are available to me, to you, and to others as well. But another part of this third criteria that we have to meet is we do not know the exact location of these pooled resources. For example, when you spin up an Amazon Elastic Compute or Amazon EC2 instance, you can select the region, but AWS is allowed to choose any data center in that AWS region. However, you can choose the availability zone if you want to. And we'll talk more about regions and availability zones in just a few minutes. AWS procures multiple resources for their AWS customers, and we're talking about thousands to make sure they are using economies of scale. And you'll learn more about economies of scales in the cost optimization for AWS, but for now, economies of scale allow AWS with the larger scale of resources to offer economies at scale to their customers, which means that AWS can pass along savings to their customers while also providing customers the resources needed to scale and grow. And this leads us to our fourth criteria that cloud computing needs, which is elasticity, which we will be talking about more throughout these fundamental lessons. But elasticity is the ability to scale with demand. So as your demand increases, you scale up your AWS resources. And then when that demand decreases, you can scale your resources down. And the fifth criteria that AWS must meet to be considered cloud computing is that the resource usage in the AWS accounts can be monitored and billed. So with AWS, we are no longer pre-provisioning, procuring your servers, storage, compute, and so on. You no longer have to estimate your demands because with AWS, we are actually scaling those resources to meet your demand instead of being over or under provisioned. And the biggest cost optimization benefit is that we only pay for what we use with AWS. So how does AWS provide such amazing cloud computing? Well, AWS offers a global infrastructure, which is a collection of smaller groupings of infrastructure that is connected by a global high-speed network. And this global infrastructure allows you to design systems that are resilient and highly available. AWS offers globally resilient services, regional resilient services, and also zonal resilient services. And as we go through the fundamentals, you will get a solid understanding of what it means to have a highly available, resilient, and fault-tolerant system. So a globally resilient service is a service that operates globally with a single database, and that data is then replicated across AWS regions. So a region can fail, but the service will continue to run, and IAM and Route 53 are examples of global resilient services in AWS. Region resilient services operate in one region with that set of data in that region and then replicate their data to multiple availability zones inside that one region. So if you lose one availability zone in that region, the service will continue to operate. But if the whole region fails, then so will your service. Availability zone resilient services are ran in a single AZ. So an exam tip is to know what level of resiliency an AWS service has, because it will help you answer exam questions, but also give you a much deeper understanding. So let's break this down. So what is the AWS Global Infrastructure? And we just said AWS created the global infrastructure as a collection of individual infrastructures located all over the world. So globally, AWS offers regions and also has AWS edge locations. And AWS is designed to have multiple regions, multiple availability zones, and multiple edge locations around the world. And then on top of this global infrastructure, we have high-level services. So we have a level of compute, and examples of compute services are EC2 and Lambda. Then we have a level of storage, like S3 or EFS. And then we also have a level of databases, so RDS, Aurora, DynamoDB. And we'll cover all of these services later under these fundamental lessons. We also have a level of migration and transfer. And one example of a migration and transfer service is AWS Snowball. We also have network and content delivery, and these services could be your Amazon VPC or CloudFront. We have a level of developer tools, robotics, blockchain, and satellite. We also have a level of management and governance, and a level of media services, a level of machine learning, which actually has its own specialty certification. But you should have an understanding of all of these high-level services, as well as analytics, security, and identity and compliance. We have a level for mobile and AR and VR, a level for application integration, and also AWS cost management. So all of these multiple different levels of services sit on top of the AWS Global Infrastructure. Dive deeper into the global infrastructure because you will see questions on your exams relating to these. So let's dive deeper too. What is an AWS region, an availability zone, and an edge location? Well, an AWS region is a geographical area that consists of two or more availability zones. So we have Northern Virginia, a London region, or Oregon region, Sydney region, and more, and each regions are under that region's rules. And so if your data sits in a particular region, your data will not leave that region unless you specifically move that data. And you will also see that some countries have multiple regions and some only have one region, and this depends on AWS and how AWS is designing their regions to be geographically spread across the world. So we can use different regions to design our infrastructure that can withstand global disasters because there is a separation between each region and each region is fault tolerant. AWS also has availability zones. And an availability zone is one or more data centers with redundant power, networking, connectivity, and they're housed in separate facilities. And these data centers sit inside different AWS regions. AWS also has multiple data centers across the world, and we can think of an availability zone as one or more data centers. And in case you don't know what a data center is, it is a building filled with servers, SAN, switches, load balancers, firewalls, storage, and more. And you can have more than one data center in each availability zone. So these availability zones are isolated, compute, storage, network, and so on, and you can distribute your infrastructure across multiple availability zones in your region for high availability. So if one availability zone fails, then the other availability zones should remain operational because the availability zones are isolated from each other, but they're connected with that high-speed redundant networking, and your services can be placed across these multiple availability zones to add resiliency and high availability. And AWS also has edge locations. Again, this is a global service, and it is an endpoint for AWS that is used for each caching content. So AWS's Content Delivery Network, or CDN, is CloudFront. And we'll cover CloudFront in much more detail later on, but basically what CloudFront offers is that if a user requests certain information, that information is cached at the edge location. So the next time another user requests that same information, that information is already available and delivered to the user much faster than if you had to go all the way back to the database and search for that specific information. Netflix uses edge locations to store content as close to their users as possible, so customers get very low latency when requesting certain movies and shows. Because the further the data that is being requested is located from customers, the slower the transfer of that data becomes. And AWS has multiple, over 150 edge locations around the world. Make sure you understand the differences between regions, availability zone, and edge locations, because you will most likely see questions around these on your exam. In the next few lessons for this fundamental series, we're going to dive deeper into AWS fundamentals. We're going to first talk about the AWS Shared Responsibility Model, and then cover the AWS Well-Architected Framework. Thanks so much for watching.